Hello students, I am N Naik, ZIT Bhubaneswar. So today we will be discussing about how to evaluate a determinant using the properties of the determinants. And prior to this, in the first session of this topic, we have learned about definition of determinants, evaluation of determinants by finding the cofactors, then inverse of a square matrix, and solution of a system of linear equations by matrix method. Now we will be coming to the properties of determinants and how to evaluate a determinant using those properties. So first of all, let us discuss about the various properties of a determinant. The first property is the value of a determinant remains unchanged if its rows and columns are interchanged. That means rows are changed into columns and columns are changed to rows. The determinant remains unchanged. Here in this case, the first row is A1, B1, C1, second row is A2, B2, C2, and third row is A3, B3, C3. Now the first row becomes first column, second row becomes second column, third row becomes third column. If we say this is determinant A and this is your determinant A dash, then we will find that the value of this determinant will be the same as the value of the second determinant. That means we can say the value of a determinant remains unchanged by changing the rows into columns and columns into rows. Second property is, if any two rows or columns of a determinant are interchanged, we are interchanging any two rows and columns, then the value of the determinant is changed by minus sign. So here in this case, the first row is A1, B1, C1, second row is A2, B2, C2, and third row is A3, B3, C3. Now we have interchanged R2 and R1. Second row comes to the place of first row and first row comes to the place of second row. So R2 is replaced by R1 and R1 is replaced by R2. So the determinant so obtained becomes A2, B2, C2, A1, B1, C1, A3, B3, C3. And we will find that the value of this determinant and the value of this determinant magnitude wise they remain the same. Only thing that they differ by a minus sign. If suppose I say the value of this determinant is delta, then the value of the second determinant will be minus delta. That means if any two rows or columns of a determinant are interchanged, the sign is reversed but the value remains same. Coming to property 3. If all the elements of a row or column of a determinant is multiplied by a non-zero constant k, then the value of the new determinant is k times the value of the original determinant. So here in this determinant we find that all the elements of the first row are multiplied by k. It is the same as multiplying the whole determinant A1, B1, C1, A2, B2, C2 and A3, B3, C3 by the same constant k, which implies A1, B1, C1, A2, B2, C2, A3, B3, C3 is 1 by m times of the determinant obtained by multiplying all the elements of the first row by m. Or even we can say it will be 1 by m into multiply all the elements of the second row by m or multiply all the elements of the third row by m. That means we can say by multiplying a determinant by a non-zero constant means multiplying all the elements of a row or of a column by the same non-zero constant. It is unlike the case of matrices where we have discussed that whenever we multiply a matrix by a non-zero constant, we multiply each and every element of the same matrix by that constant. But in case of determinant, whenever we multiply a determinant by a constant, that means we multiply all the elements elements of a row or of a column by the same constant. Next is your property 4. If each element of any row or column consists of the sum of two or more terms, then the determinant can be expressed as the sum of two or more determinants. Here we find that all the elements of first column are expressed as sum of two terms, a1 plus x, a2 plus y, a3 plus z. Now this determinant can be expressed as sum of two determinants. The first determinant will be obtained by taking the first terms, then b1, b2, b3, c1, c2, c3 plus the second determinant is obtained by taking the second terms x, y, z, then b1, c1, b2, c2 and b3, c3. So now to summarize, we can say if all the elements of any row or column of a determinant are expressed as sum of two or more terms, then the determinant is expressed as sum of two or more determinants. Now this property 5, it is more important because this property will be used for solving most of the problems. The value of a determinant is unchanged if any row or column is multiplied by a number and then added to any other row or column. So here we have applied C1 replaced by C1 plus m times of C2 minus n times of C3. So by doing this, the value of the determinant remains unchanged. That means to a particular row or column, we can add or subtract a constant multiple of sum of the row or column or sum of the rows or columns. Property 6 is if any two rows or columns of a determinant are identical or even equal, then its value is 0. Here we find that here is A1, B1, C1. The first row comprises of the elements A1, B1, C1 and the third row again the same elements A1, B1, C1. That means these two rows have the same elements. So these two rows are equal. Then the determinant will vanish. The seventh property is if each element of a row or of a column of a determinant is 0, then its value becomes 0. That means if in a row or in a column all the elements are zeros, then the determinant vanishes. So these are the 7 properties we have discussed. Now using these 7 properties, we will solve some of the problems. So question is evaluate this determinant using properties. 6 minus 3, 2, 2 minus 1, 2, minus 10, 5, 2. We have to evaluate this determinant. Here direct evaluation is not allowed. We have to evaluate this determinant using the properties of the determinants. We can find that in the first column, 6 means this can be written as minus 3 into minus 2. 2 can be written as minus 1 into minus 2. And minus 10 can be written as 5 into minus 2. That means we find that minus 2 is present everywhere in the first column. And that can be taken out because we have discussed the property that if all the elements of a column or of a row are multiplied by the same constant, that constant can be taken out. That means that constant can be multiplied with the whole determinant. So by taking out the common factor minus 2, we are left with minus 3 minus 1, 5 in the first column. Then second column and third column remains as it is. So now here you observe that in this determinant, so here it is minus 3 minus 1, 5. That means first column and second column, they are equal. And again the property says, if any two rows or columns of a determinant are equal, the determinant vanishes. So it is minus 2 into this value of the determinant becomes 0. So this becomes 0. So we have not evaluated this determinant, rather we have evaluated it using the properties. So direct evaluation is not permitted here. Whenever we are asked to evaluate the determinant using properties, we cannot have the direct evaluation. Example 2, evaluate the determinant. This is an important question. So first column 1, 1, 1. Second column A, B, C. Third column is B plus C, C plus A plus B. Again, we can apply the property that here all the elements of a column are expressed as sum of two elements, and this can be expressed as sum of two determinants, but that will be a bit lengthy. Rather, we'll try to take out the common factor. So first of all, let us understand the principle of evaluating the determinant by using properties. The very first thing we have to remember that we'll search for the common factor in a row or in a column. If we have the common factor, then that can be taken out. If we don't have the common factor, then we have to try to bring the common factor by applying the property. So here we have applied the property. Column 3 is replaced by column 3 plus column 2. That means column 2 is multiplied by 1 and added to column 3. Thereby the column 3 becomes A plus B plus C, A plus B plus C, A plus B plus C. That means we have got the same element everywhere in column 3. So that can be taken out. First column and second column remains as it is. Only thing that we have changed column 3 by applying the property just to get the common factor. So this common factor A plus B plus C is taken out. We are left with 1, 1, 1, A, B, C, then here 1, 1, 1. Now we observe that these two columns, means first column and third column, are identical or equal. So the determinant vanishes. This determinant becomes 0, and 0 multiplied by A plus B plus C, again it is 0. Here again we have not directly evaluated the determinant by getting cofactors and minors. Rather, we have evaluated the determinant by using properties of the determinants. One more example. Evaluate the determinant A, B, C, A square, B square, C square, B, C, C, A, B. So first of all, we search for the common factor either in a row or in a column. So here we don't have any common factor. First row don't have any common factor. In the second row we don't have any common factor. In the third row again we don't have any common factor. So we didn't get any common factor in any row. Likewise, we can search in the columns also. Again, the first column, no common factor. Second column, no common factor. Third column also, there is no common factor. So that means we fail to get any common factor from either any row or any column. Now the next step, we have to try to get the common factor by applying the property. So now, we have applied the property that C1 is replaced by C1 minus C2 and C2 is replaced by C2 minus C3. So C1 is replaced by C1 minus C2 and C2 is replaced by C2 minus C3. By doing that, the first column becomes A minus B, A square minus B square, which in terms becomes A minus B into A plus B, and the third element becomes BC minus CA. Taking minus C out, it becomes A minus B. That means we have arranged them in such a way that we are getting A minus B as the common factor. Now the second column C2 replaced by C2 minus C3. So it will be B minus C, B square minus C square, which is B minus C into B plus C. And it is CA minus AB. Taking minus A common, it becomes B minus C. Again we have arranged them so that we are getting B minus C as a common factor. And the third column C, C square and AB, it remains as it is. There is no change. Now A minus B is present everywhere in the first column. B minus C is present everywhere in the second column. So we can take A minus B and B minus C out. And by doing that, we are left with 1 a plus b and a minus c in the first column, 1 b plus c and minus a in the second column, c square a in the third column. So now we'll try to get as many zeros as possible, either in minimum of 2 zeros, either in a row or in a column. So now to get 0, we have applied the property C1 replaced by C1 minus C2. So C1 is replaced by C1 minus C2. By doing that, 1 minus 1 will be 0. So here BB will be cancelled out. We will be left with A minus C. And here minus C minus of minus A becomes A minus C. Again we are getting the common factor, either A minus C or minus of C minus A. In addition to that, we have got zeros. Now 0 means it is 0 into C minus A. Here is C minus A, here is also C minus A. We can take C minus A out. So we will be left with 0, minus 1. So taking minus sign also out, we will be left with plus 1. Here also plus 1. Now second column and third column remains as it is. Now we need 2 zeros, either in a row or in a column. Already we have got 1 0 here. Now let us make this quantity as 0, this one as 0, by applying the property R2 replaced by R2 minus R3. So this total quantity remains as it is. Now first row remains as it is. Only thing that there is change in second row. How it is changed? It is changed by R2 minus R3. So 1 minus 1, 0. B plus C minus of minus A becomes A plus B plus C, and this will be C square minus AB, and no change in the third row. One thing here we can remember, that in a particular step we are free to apply either row operation or column operation, because property allows us that if in a determinant rows are changed to columns and columns are changed to rows, there is no change in the value of the determinant. That's why. So we can apply column operation or row operation as per our convenience. Now we have got 2 zeros in the column. So expand it along the first column. So expanding it along the first column C1, we get it is A minus B, B minus C, C minus A, and that minus sign remains as it is. So now it is our usual evaluation. 0 into cofactor of 0 becomes 0. Then 0 into cofactor of 0 becomes 0. Then 1 into cofactor of 1. So 1 into C square minus AB minus C into A plus B plus C. So we are getting minus of C square minus AB minus AC minus BC minus C square. So C square cancelled. Minus sign multiplied with minus AB minus AC minus BC, that becomes plus AB plus BC plus AC. So together it becomes A minus B into B minus C into C minus A into AB plus BC plus CA. So whenever we evaluate this determinant ABC, A square B square C square BC CA AB, that becomes A minus B into B minus C into C minus A into AB plus BC plus CA. Also same question, we may be asked to prove that this determinant is equal to A minus B into B minus C into C minus A into AB plus BC plus CA using properties. So let us discuss one more question. Without expanding the determinant, prove that this determinant is x cube. So we have taken the left hand side, 3x plus y, 2x x, 4x plus 3y, 3x 3x, 5x plus 6y, 4x 6x. Now here we find that all the elements of the first column are expressed as sum of two elements. Now the whole determinant can be expressed as the sum of two determinants. So the first determinant will be 3x, 4x, 5x. Then the other two columns remains as it is, plus the second determinant is y, 3y, 6y, and the other two columns remain same. Now here in the first determinant we find that X is common in the first row. X is also present in the second row. X is present in the third row. So from the first row we can take X common. Second row we can take X common. Third row again we can take X common. That means thereby we are getting XQ as the common factor. So we are left with 3, 2, 1, 4, 3, 3, 5, 4, 6. Now here we find that in the second column everywhere we have got X, and in the third column again everywhere we have got X, and in the first column we have got Y. So we can take X, X and Y. That means X square Y common. We are left with 1, 3, 6, 2, 3, 4, 1, 3, 6. So that becomes XQ into same determinant remains as it is. And here we find that it is a C1 and C2. C1 and C2 are identical. C1 and C2 are identical. This multiplying 1 by 2 we are getting 2. Then C1 and C2. C1 and C2 are identical in second determinant. Column 2, 3, 6, 1, 3, 6. Oh sorry, 1 C1, 1, 3, 6 and 1, 3, 6. That means C1 and C3 are identical. So the determinant vanishes. The first column and the third column, they are equal. So the determinant vanishes. So this becomes X square Y into 0. That becomes 0. So we are left with XQ into this determinant. So it is XQ into 3, 2, 1, 4, 3, 3, 5, 4, 6. Now we'll further simplify this determinant. Now say XQ into, we have applied the property C1 replaced by C1 minus C2. By doing that, it will be 3 minus 2, 1, 4 minus 3, 1, 5 minus 4, 1. Means the elements have become simpler. So it is 3, 1, 1, 1, 2, 3, 4, 1, 3, 6. Now before evaluating or before expanding, we need two zeros, either in a row or in a column. So XQ remains as it is. We have got 0 here and 0 here. By applying the property R2 replaced by R2 minus R1 and R3 replaced by R3 minus R2. R3 means R1 remains as it is, 1 to 1. R2 replaced by R2 minus R1. So 1 minus 1, 0. 3 minus 2 is 1. 3 minus 1 is 2. Now R3 is replaced by R3 minus R2. That means 1 minus 1, 0. 4 minus 3, 1. 6 minus 3, 3. So this is our determinant. Now we can directly expand this along the first column. So it is XQ into 1 into cofactor of 1. It is 1 into 3, 3 minus 1 into 2, 2. So it is XQ into 3 minus 2. That becomes XQ. Now let us prove one more question. The determinant X plus A, B, C, A X plus B, C, A, B, X plus C. This will be equal to X square into X into A, X plus A plus B plus C. We have to prove this. So now our LHS is X plus A, B, C, A X plus B, C, A, B, X plus C. Now we need to get the common factor. First of all, we search for the common factor either in a row or in a column, but we don't have any common factor. Now we try to get the common factor by applying the property. So if I apply the property C1 is replaced by C1 plus C2 plus C3, we find that this element becomes X plus A plus B plus C. This element becomes X plus A plus B plus C, and this element becomes X plus A plus B plus C. Other two columns remain as it is. Now this is the common factor because it is present everywhere in the first column. So taking X plus A plus B plus C common, we will be left with 1, 1, 1. Other two columns remain the same. Now we will try to get as many zeros as possible, preferably two zeros, either in a row or in a column. So it is x plus a plus b plus c. Now applying the property R2 replaced by R2 minus R1 and R3 replaced by R3 minus R1. So we are getting 1 BC 0x0 0 0x. Now we can expand it along the first column. So it will be x plus a plus b plus c will be left with x plus a plus b plus c. Now 1 into cofactor of 1, that is x square minus 0. So it is x square into x plus a plus b plus c, that is the right hand side. Then one more example. We will prove that x plus 4 2x 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 x plus 4 2x 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 x plus 4 is equal to 5x plus 4 into 4 minus x whole square. So that means this determinant must be equal to this. So already we have discussed that we search for the common factor. So there is no common factor in the first row, it is not there in the second row, it is not there in the third row. Similarly, column wise there is no common factor. Now we try to get the common factor. Then for which factor we will search for? Either we will search for the common factor 5x plus 4 or 4 minus x. So then how to apply the property to get either this or this? So applying the property C1 replaced by C1 plus C2 plus C3. Column 1 is replaced by column 1 plus column 2 plus column 3. So 2x plus 2x, 4x plus x becomes 5x plus 4. Similarly, 2x plus x plus 4 plus 2x becomes 5x plus 4. And x plus 4 plus 2x plus 2x becomes 5x plus 4. That means now we have got the common factor 5x plus 4. And we require it in the right hand side. So taking that 5x plus 4 out, we will be left with 1, 1, 1. Other two columns remain as it is. So it is 5x plus 4. Then our next step is try to get as many zeros as possible, preferably two zeros either in a row or in a column. So for this, we have applied the property R2 replaced by R2 minus R1 and R3 replaced by R3 minus R2. So it is R3 replaced by R3 minus R1. So 1 minus 1 0, 2x minus 2x 0, x plus 4 minus 2x becomes minus x. So it is, we are getting 1 2x 2x 0 minus of x minus 4 0, then 0 x minus 4 minus of x minus 4. Now we have got two zeros along the first column. Now we expand it along the first column. So it is 5x plus 4 plus 1 into cofactor of 1. So minus of x minus 4 into minus of x minus 4. That becomes x minus 4 whole square minus 0 into x minus 4 becomes 0. So ultimately we are getting 5x plus 4 into 4 minus x whole square. So now there are some of the questions given as homework. So please try to solve these questions. So thank you.